In section 8.4, we're going to continue with our finance, but we're going to switch from the idea of simple interest and move into something called compound interest. Now, in compound interest, periodically, a financial institution will stop, calculate your interest, and add it on to your principal. And then when they stop again, when that same period has passed, and that might be a year or 6 months or 1 month, when it passes again, they calculate interest again, but this time the old interest is added into the principal. So your investments grow more, they grow bigger because you're constantly adding in more money into the principal for the next time that they calculate interest. I'm not going to go through the derivation of the formula, but it is in your textbook and it is in this little box, and it says if you deposit P dollars, that would be your present value, sometimes called the principal, at a rate of R, that's your interest rate, subject to compound interest paid N times per year. And remember I said periodically. Then the amount A, that's your future value, of the money in the account after T years is given by. And here is a formula. It's quite different than the simple interest formula, and it is an exponential formula. It has an exponent here. We are going to, in this class, use our calculators to do this. So I will teach this with the calculator. I'm going to be using the TI-84, and you might be using an emulator on your smartphone as well. All right, something that we do need to talk about is, whoops, I just moved that way too big. When I said that they periodically stop, you need to be aware of the words that indicate the number of compounding periods per year. So if it says, and it says it in words, semi-annual compounding, that means that the number of compounding periods per year is 2. If it says quarterly, it is 4. If it says monthly, it's 12. Now, they use, for the number of periods per year, little n. We will be using our graphing calculators, and they have a slightly different way of doing things, and we will use something called a TVM solver. This is time, value, money solver. Capital N is the total number of periods over the time of the loan or the investment. So capital N is little n times T. So if it was compounded semi-annually for 5 years, our capital N would be 10. So I'll talk more about that as we do our problems. So for every problem, we've got future value, we've got principal or present value, we've got interest rate, we have compounding periods, and we have T, which is time. So let's take a look, and I'm going to go slowly through using the TVM solver. Make sure that you have one, a graphing calculator or an emulator available. All right, the first thing I'm going to do, and I'm going to do this every time that the problem is compounded, and it will say it is compounded. If it's simple, it will say it's simple interest. I'm going to write down the values that I'm going to use in the graphing calculator. I have capital N, I%, PV, PMT, FV, P/Y, C/Y, and then the default at the bottom will always be N. Okay, I'll talk about what each one of these is. And it is written out in your handout for this section. All right, capital N is the total number of periods. total number of periods. And remember that it is little n times t. That's right up here. So in our problem, we have a principal, 3,000. We have a rate of 6%. It is compounded annually. That means that little n is 1. Little n. Remember, that's different than capital N. And the time is 2. Don't worry, I'm going to show you how to use a graphing calculator in just a minute. Okay, capital N. Remember that it is little n times t. So it is 1 times 2, which of course the calculator is going to say that that's 2. I%. Now this is something different than what we did with simple interest. You put in the 6 and you do not change it to a decimal. You notice it says I%, so it wants 6. Present value, that's the same as principal, so we're going to put in 3,000. Payment. Compound interest problems that we're looking at today do not have payments. We'll look at applications of payments later, and so that will be a 0. Future value, well, that's what we're looking for. How much money will be in the account? So that's my question. Periods per year, this is little n. And compounding per year, that will always be the same. In our problems, P per year and C per year will always be the same. So periods per year, compounds per year, they're the same for us. And end will be highlighted. All right, let's see what it looks like on the calculator. All right, I'm going to clear all of this. I want to clear everything. Well, let me just go second quit. Okay, I'm on the home screen. In order to use this application, I go to the button that says Apps. Okay, everybody find Apps? I'm going to choose Finance. Now, you can either just hit Enter because Finance is already chosen, or you can hit a 1. These are the calculations that it can do for us, and we're going to choose number 1 again. It's the TVM solver, 1 again. So we did Apps, Finance, 1, 1. Okay, let me move my problem over here. All right, I had been playing with this a few minutes ago, so I have some values in it. Okay, N, capital N is the number of periods per year times the number of years. So if you want to, you can put 1, whoops, 1 times 2. Now I know that you knew that was 2, but sometimes when the problems get more complicated, it's nice to let the grapher do that multiplication for you. So click Enter. See how it changed it to 2? The I% is 6, and I have a 6 in there, so you type a 6, and I'll press Enter. The present value is what we started with, and I believe that I have the wrong number. Did we have 30,000? No, it was 3,000. Okay, so 3,000. Payment is 0. When I get to future value, I can either skip it or clear it. You can just skip it or you can clear it. Some people like it to be blank because that's where our answer is going to go. P per Y, that's little n, that's 1, and C per Y, that's 1, and it should stay on end. Whoops. Everybody got theirs in? Pause this video if you need some time to clean yours up. Now, this is important. In order to get it to calculate the future value, how much will be in this account after this many compounding periods for this amount of time and so on, you're going to click alpha, and then the alpha of the enter key, which is in the green, says solve. So it's going to be alpha enter while it's sitting there, enter. And it gives me a value. Go to the item you're getting it to solve for. You fill in everything you know. Leave blank the one you don't know that you're solving for. Put your cursor there. Then do alpha, enter, and it comes up. Now, it comes up negative. This software is designed like financial software where things are checks and balances, positives and negatives. You're just going to have to learn to ignore that negative sign. Your answer, how much money will there be, is $3,370.80. Okay, now I'm going to do this. I'm going to grab this and put it here in your notes so that you have it. Now it says the amount of interest earned. Well, you don't really have to have a formula for this, but the interest is the future value minus the present value. So it is 3,370.80 minus the 3,000 that we started with, so it's $370.80. And I think that is just good common sense. Okay? So every time we're going to write these guys down. Let's go to our next problem. All right. I'm going to write down N, I%, PV, PMT, FV for future value, periods per year, compounds per year, and then it will say end. All right, let's look. In this scenario, it is compounded semi-annually. That means little n is 2. Okay, this will be a 2 and this will be a 2. It is in the account for 5 years. So it is 2 times 5, n times t. Total number of periods. 10 times they will calculate interest. The interest rate as a percent in this case is 5. The present value, $7,000. Payment, 0. Future value, that's what we don't know. Let's see what it's like to put this all in the calculator. All right, go up to the top. I used my up arrow to do that. And the number of compounding periods, let me scoot this up a little bit, is 2 times 5, and you certainly could just do 10. Enter. The interest rate is 5. Enter. The present value is 7,000. Enter. Whoops, I messed up on that. Let me go back up and over and delete one of those zeros. The payment is 0. The future value, I'm going to push clear because I don't know what it is. Payments per year. Come on down. I guess it wanted a number in there. Okay. So leave the number in there. Don't clear it out yet because it won't move away. I apologize. Okay, 2, enter, to enter. Now, why did I put 55? I just hit the 5. I had to have a number in there to go away. I couldn't move past it blank, and that was my mistake for telling you to do that. Once you've finished, now you can clear it. Once you've got everything in but the one you're looking for, then what do you press? Alpha, enter. And our how much will be in the account will be $8,960.59. How much of that is interest? The amount of interest earned? Well, remember that interest is the future value minus the present value, 8960.59 minus 7,000 gives us, and remember on this 8960, that was negative, but we're going to learn to ignore it. So this is $1,960.59. Let me go grab this screen. And put it right there for you. You notice that it has a negative, but we're going to answer it positive. That's just a programming, the way it's done with Financial Talk. All right, next one. We've got a principal of $10,000, 3% interest, compounded quarterly. Quarterly. Little n is 4 times a year. They do it for 5 years. All right, so I have N, I percent, PV, PMT, FV, P per Y, C per Y, and I'm not going to write that end. We're just going to leave it as end on all these problems. That has to do with whether they do the compounding at the beginning of a period or at the end of a period. And it's very typical for it to be end. All right. Total number of periods, 4 per year for 5 years. 4 times 5, it will change that to 20. Or you can just put 20 in. The percent is 3. The present value is 10,000. Payment, there are no payments. This is 0. Future value, unknown. And because it is compounded quarterly, those are both 4s. Okay, so let's go to the grapher and go up to the top. And if you want to, you could just type the 20 in. And then 3. You can either use the down arrow or you can use enter. The present value is $10,000. There's a little delay on mine, so sometimes I hit it wrong. The payment is 0. I'm leaving the future value. I'll change it in a minute. But remember, I have to have a number in there. Whoops. Where did it go? Hold on just 1 second. Okay, I'm sorry, I'm not sure. Some of my stuff disappeared. All right, so 10,000, the payment was 0. I skipped that. Periods per year is 4. And that one is 4 also. Go back up to the future value. You don't even have to clear it. If you just do alpha, enter, it will put the new correct one in there. And so our future value, what we'll have in this account, will be $11,611.84. The amount of interest, well, we know how to get interest. We're going to take our future value minus our present value. So it's $11,611.84 minus 10,000, which gives me interest of $1,611.84. Okay, let's grab that and put it right there. Okay. Let's look at another one. Hopefully we can pick up the pace. All right, we have for number 4, we have N, I%, PV, PMT, FV, P per Y, C per Y, end. All right. We've got $8,000. Okay, that's my present value. 6.5%, literally put in 6.5. Monthly, that means that little n is 12. So these two will be 12. But it's 12 times a year for 3 years. So it's 12 times 3. That'll turn into 36. My payment is 0, and my future value, how much money will there be in the account? So that's my future value. All right, to the grapher. All right, I have for capital N, it is 12 times 3, or you could have just put in 36, 6.5%. Present value, 8,000. Payment remains 0. Future value, I'm skipping it. Periods per year, 12. 12. All right, go back up to, future value. You can clear it if you want to, or you don't have to. And you're going to do alpha, enter. So my future value after 3 years, compounding it monthly at this interest rate, I will have $9,717.37. That means that my interest will be $9,717.37 minus what I started with, which is $8,000, giving me interest of $1,717.37. And I will grab this for your, so you have it for your notes. Oops. Okay. Remember, you can pause this anytime you want. Go back and watch me do it with the calculator. This is so much easier than doing it with the actual formula. Number 5. All right. Hopefully you're on a roll. We have N, I%, present value, payment, future value, P per Y, C per Y. All right, in this one, it is compounded daily. And for financial reasons, we're going to say that that's 360. So every single day, at the end of the day, they compound and add your interest on. They're going to do that for 5 years. So 360 times 5. Your interest rate is 7.5. Present value, the investment, is 8,000. Payment is 0. Future value, that's what we're looking for. To the calculator. In case you've forgotten, we went apps, 1, 1, and we're there. All right. The total number of periods is 360 times 5. The interest rate is 7.5. Present value is 8,000. 0 payment, skip the future value. Payment periods per year, 360. And it changes that next one automatically. So now we go up to future value. That's what we're looking for. That was the last one. And I do alpha, enter. And my future value is $11,639.48. What's my interest? Well, it's $11,639.48 minus my present value, what I started with, which is $8,000. So I have interest of $3,639.48. So that's a good bit of interest. But it was 5 years, and that was a nice interest rate. Okay. All right. Now, in the next problem, we're going to do something a little bit new. So let me go ahead and introduce something else to you. We can compound once a year. We can compound twice a year, 4 times a year, every month, daily. But what if we let the number of compounding periods approach infinity? It's as if from every nanosecond to the next nanosecond, the interest is being added on. It's called continuous compounding. And this formula actually involves a little calculus to get a hold of. We're not going to go over the derivation, but I'm going to give you the formula for continuous compounding. Now, you'll notice it will literally say the word continuous. And it is different than monthly or quarterly. It says continuously or continuous compounding. We do not use the TVM. We use the home screen. And the formula is future value, A, is equal to P times E to the RT. Now, a little note. E is Euler's number. You've worked with weird numbers before that had letter names like pi. Well, E is Euler's number. He was the mathematician that came up with this. And E is approximately, just approximately, 2.7. We're not going to use 2.7, but I want you to realize that it's a number. Perhaps in a class, I could talk to you about where it comes from, but for right now, I'm just going to say it's a number. All right. We're going to do this on our home screen of our calculator, and I will show you how to do this on the very next problem. So, please make sure that you have this continuous compounding formula written down, and you'll get to use that E in just a minute. All right. Number 6 has some comparisons to do. It says find the accumulated value, that would be future value, of investment of $15,000 for 5 years at an interest rate of 4.5% if the money is compounded semi-annually, that's twice a year, quarterly, that's 4 times a year, monthly, 12 times a year, or continuously. And we're going to see how does that affect what the future value is. Okay, so what I'm going to do is just start out with capital N, I%, PV, PMT, FV, P per Y, C per Y, and then it'll say end. Now, I'm going to make myself a little chart. This is not going to be perfectly neat because with this I don't have any way to use a ruler. And I'm going to look at Part A, Part B, please come back. Where did it go? There it is. Part C and Part D. Okay. Let's see. Some of these are always the same. The present value is always 15,000. All right, this one is continuously, so it's different than all the rest. I will do this separate. All right, 5 years, okay, at an interest rate of 4.5, so 4.5, 4.5, 4.5, 4.5. Payments are 0. Future value I'm looking for. Now, periods per year. For Part A, semi-annually means twice. For Part B, quarterly, 4. For Part C, monthly, 12. And that's not relevant for the continuous. N, remember N is little n times T, so this one is 2 times 5, 4 times 5, and 12 times 5. All right, everybody with me? All right, let's get our grapher. All right, for Part A, and I'm going to try to put my answers in here if they're not, well, they're pretty big, but all right, 2 times 5. Interest rate is 4.5. The present value is 15,000. Payments are 0. Because it is semi-annually, payments, periods per year, compounding per year is 2. All right, so go up to future value, alpha, enter. And in this scenario, I will have I will have 18,000. You know I'm not going to have enough room, so I will just write it over here. For the first one, I'll have $18,738.05. I know it's off the screen, but I know what it was. Okay. Now for the second part, I only have to change a few things. I have to change these two to 4s. And I have to change the top one to 4 times 5, or just type in a 20. And now go back down to future value and do alpha, enter. And for this one, I get $18,761.26. You can see that it is a little bit more. And that's because instead of just compounding it after 6 months and then compounding again at the end of each year, they did it every 3 months, which is what quarterly means. So the more often they compound, then the more money goes into the principal bucket, and then there's more interest made on that. All right, next one. The number of compounding periods is now 12 times 5. And these are both 12. And we'll go back up, whoops, and sit on future value, alpha, enter. And we get $18,776.94. Okay, so these were just our questions. All right, now continuous. I'm going to do that. Give myself a little more room. All right, for continuous, the formula is A is equal to P E to the RT power. Okay. The amount is the future value, the principal, 15,000. Then we will have the E representing a particular number is an irrational number. Remember, it's about 2.7. We're going to raise it, and my notation for that is the little caret sign. And it's very important that you put parentheses and you multiply the rate times the time. And because we're not using the TVM solver anymore, we have to change the rate to a decimal ourselves. Okay? Times the time was 5 years. You notice there's no n. That's because it is compounding not periodically, but continuously. So you have to remember that when you're using a home screen calculation, you have to change the interest rate to a decimal. But if you're using the TVM solver, you get to put it in as its percent number. All right, let me show you how to do this on the graphing calculator. I will do a second of the mode key, which is quit. If there's anything on my home screen, I'll do clear until it's gone. All right, I'm going to type in 15,000. Now, I need to raise E to a power. It's tiny on here, but look at your first column of keys. The second function of your LN key is a key that says E to the X. So do second of the LN key. You will get the little E, and you may just get the caret key that I had. All right, now, I suggest that you use parentheses. Just makes it safer. All right, it's 0.045 times 5, close parentheses. Press enter. All right, I got $18,784.84. Let me grab this. I'm not sure why this is doing this occasionally, but it is. All my work over here disappeared, and I'm having to tap things to get it to come back. This is all neatly written out for you in the printable notes. All right. How about I put this right over here? And my answer is, oops, $18,784.84. So you can see that as we increase the number of compounding periods per year, our future value goes up. The maximum being when we compound it continuously. Now, I didn't put the little charts for each one of these, but I did do the compound interest. And on your grapher, you may actually have that symbol. And let me show you where that is. It is right there, if you need it. But when you do second of the LN key on some of the graphers, depending on your model, it will show that. All right. So that was a good bit of work. All right. Now we're going to, it says, suppose you have $15,000 to invest. Which of the two rates would yield the larger amount in 3 years? 9% compounded daily, or 8.87 compounded continuously. Okay, so we're going to compare different interest rates with different compounding periods or continuous. So I have two problems to do. All right, for the first one, the one that's compounding daily. We have N I percent, because I'm going to use the TVM solver to do this. Present value, payment, future value, P per Y, C per Y. For continuous, I will use A is equal to P E to the RT power, and I will do it on the home screen. All right, so for the first one, we have $15,000. That's our present value. And 3 years is our time. We'll use that in a minute. 9% compounded daily. 9%, if it's daily, there are 360 periods or compounds per year. We're doing it for 3 years, so it's 360 times 3 for the total number. Payment's still 0, and this is what I'm looking for. Continuous, we will do 15,000 E raised to the interest rate, which is 0.0887 times the time, which is 3 years. P times E to the R times T power. All right, so I've got two different calculations to do, different ways in my calculator. All right, let's do app, finance, TVM solver. I have 360 periods per year for 3 years, so 360 times 3. I have a nice big interest rate of 9%. 15,000, which happens to be the number I already had in there. No payment. Future value we skip. Payments per year, periods per year is 360. Go back up to future value. Clear it if you want to, it doesn't matter. And do alpha, enter. And we will have a future value of, let's see, where will I write this? All right. It will be $19,648.80. All right, now let's do the continuous. To do continuous, I need to get to my home screen. Second of the mode key says quit. So I have 15,000. Second of the LN key, I'm going to open parentheses. I'm always going to open parentheses for that product up there in the exponent. 0.0887. Remember, you have to change the percent to a decimal because you're on the home screen. Times 3, close your parentheses. Press enter. And I get $19,572.98. Let me put that screen. Now, this question does not ask us for any of those numbers. Instead, it says which of the two rates would yield the larger amount in 3 years. And you can see that the 9% gave you slightly higher future value. Okay? right, we're going to switch things up just a little bit. In problem number 8, it says how much money should be deposited today? Oh, that's asking about the present value. In an account that earns 7% compounded semi-annually so that it will accumulate $11,000 in 3 years. Okay, still going to use our TVM solver. All right, I have N, I percent, present value, payment, future value, P per Y, C per Y. All right. 7%, okay. Compounded semi-annually. That means that these are 2 times a year. Semi-annually is twice a year. We're going to do it for 3 years. So my capital N is 2 times a year for 3 years. My present value this time is what I don't know. My payment is still 0. My future value, that's what I want to have at the end of 3 years, is $11,000. So the only thing that's different is that this time I'm looking for a present value. I will do apps, 1, all right. Gotta put this somewhere where I can see my work. All right. In for N, I have 2 times 3, enter. Interest rate is 7. Present value, I don't know. Payment is 0. Now, future value. We've been getting a future value that's negative. Present value and future value, whichever one you put in, one has to be positive and one has to be negative. So it's up to you. If you're used to this being negative, we'll put in negative 11,000. And there are 2 periods per year. So present value and future value, one's going to be positive and one's going to be negative. So now let's go up to present value, do alpha, enter, and it says that we need to invest now. Our present value is $8,948.51 in order to have $11,000 at the end of our 3 years. Okay, now let me show you this. If I had put in positive 11,000 and went back up to present value and did second alpha, it would simply give me a negative present value. Present value and future value are always going to have opposite signs using this technology. Okay, we have something new starting with number 9. It says determine the effective annual yield for each investment, then select the better investment. Assume 360 days in a year. That's in case it's compounded daily. Here's the definition. The effective annual yield or effective rate is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. Now, what that's really saying is they want us to compare. Now, you notice they did not give us any money. When we find the effective rate, we are taking 2 different situations and trying to kind of find a common denominator. So any particular amount of money, if it is compounded monthly at 10% compared to compounded annually at 10.25%. we can figure out which will be the better deal. We do that by finding the effective rate, which is kind of like what the simple interest rate would be. Now, we don't have to use the formula that the book uses. We're going to use the calculator again, and I'll show you where to find this. It's still under finance, but instead of the TVM solver, it is EFF. Inside parentheses, you will type in the I%, comma, the periods per year, which is little n, and then you'll type enter. So let's do that. We're going to do, we're going to do 10% compounded monthly, little n is 12. And I'm actually going to change that. Periods per year is 12. We're going to compare that to 10.25 when the when the periods per year is 1. All right, so let me show you on the calculator how to do that. All right, I'm going to do second quit. That gets me back to the home screen. Go to apps, choose finance, but we're going to scroll way down. Whoop, I scrolled way too far down. I just wrapped around. Let me go back again. All right, it is choice C. So it goes 1 through 0 and then A, B, C. So we're going to choose C. Now what you do is you choose C and you press enter. You're on the home screen. The parentheses are open. You're going to type in 10 for the 10%. You're going to do a comma. This key right here is the comma. Then you're going to type in a 12, close those parentheses, and press enter. Okay, and I got 10.47. So let me go back. Whoops. All right, and I got 10.47%. That is as if the simple interest rate, where you didn't compound it every month, was 10.47. All right, doing it in this scenario, we will do apps 1. Let me see if I can do letter C. Alpha program is C, and it, sure enough, that worked. That was a little shortcut. See that little C right there? Rather than scrolling. All right, and I have 10.25, comma, 1. Now I have a feeling that's what I thought was going to happen, that if you're just compounding at the end of 1 year, it's as if it is simple interest. All right, this is the effective rate for each one of these. You can take two different conditions and compare them by changing them both over to their effective rates, and you can see that this one is higher. So you will want to make note of this for effective annual yield. It's under finance and it's choice C. All right, let's do one final problem. All right, how much more would you earn in the first investment than the second? All right, we will have N, I%, PV, PMT, FV, P per year, C per year. All right. In the first one, let's see, we're going to do 50 years compounded annually. Now, if we compound annually, it's once a year. So this is 50 times 1. This one is also 50 times 1. The interest rate for the first one is 10%, and for the second one is 5%. Both of them have a present value of $22,000. Zero payment, looking for future value, and this one was annually also. So let's see. You know what I want to do is I want to grab this and send it back up to that previous question. Okay. I knew that was still on the screen. All right. Apps. Choose Finance. Choose the TVM solver. And let's pull it over here. The first one, 50 times 1 is 50. 10%. Present value, $22,000. Zero payment, don't know the future value. It is compounded annually, which means that those are 1. Go up to the future value, do alpha, enter, and now remember, this was for 50 years. So the future value here is $2,582,598.76. Wow. Let's go back up and drop that interest rate from 10% to only 5%. And do alpha, enter, and we get drastically different number. $252,282.80. Now it says, how much more would you earn on the first one than the second one? So you're going to subtract $2,582,598 and some cents. You're going to subtract this from it, and you will get, and I think it says to round to the nearest dollar, you will get $2,330,316 more by getting it at 10% than at 5%, because the time was the same, the frequency of compounding was the same, the investment was the same, but my goodness, there was a huge effect because of the interest rate. All right, that was a very long lesson. That took us an hour, and it will take a while to do the homework, but certainly not as long as that. All right, good luck.